Hello, everyone. This is Christina Jang from ITDP, and I would like to welcome you to our webinar today. First and foremost, I hope you, your family, and your friends are safe and healthy. Thank you again for choosing to spend your time with us today and for engaging the ITDP community during these times. Again, thank you for joining our webinar today, which is titled Complete Streets, Finding Space for Freight. Before we begin, there are a few housekeeping items. Please note this webinar will be recorded and both the recording and PowerPoint will be shared with you within a week. To interact with me and our host, Dr. Alison Conway today, you can submit questions through the Q&A function, which is at the top or the bottom of your Zoom screen. I also encourage you to submit questions throughout the presentation because it will not interrupt the slideshow today. Again, today is our host, Dr. Alison Conway, to join us to discuss how during this time of enormous growth in on-demand e-commerce, freight travel behavior patterns have become distinct and rapidly evolving, generating unique demands for on and even off-street spaces. Today, she will review challenges identified in a survey of cities around the US and discuss international best practices to approach design, regulations, operations, and demand management for freight. Dr. Conway is also a previous MOBILIZE speaker, and today she'll present on urban freight, which is a preview of some of the agenda topics that we will have for MOBILIZE 2020. She is currently an associate professor of civil engineering at the City College of New York and a member of the research team for Metro Freight, a Volvo Research and Education Foundation Center of Excellence in Urban Freight. Now I can hand it off to you, Alison, and you can begin to share your screen.
Great, thank you, Christina. Okay, so just getting this running on the presentation. Thank you, Christina, and thank you to ITDP for the opportunity to present on this webinar. Glad to be able to share this work with such a global audience with a variety of expertise. So what I'm going to talk about today primarily is a guidebook that we developed with input from a number of US cities. Those are shown on the map to your right. We also, after surveying US cities to identify what the challenges they face, look to the global community for the types of solutions that we need to address these common challenges for urban goods movement in cities. So the bulk of my presentation today is going to be on those challenges and solution approaches. Towards the end of the webinar, I will talk about demand management strategies. So not just addressing freight issues as freight is operating today, but how can we actually try to shift the demand and what are different approaches to do that? And then finally, at the very end, as I imagine you're doing in any webinar you're attending in current environment, we will touch on at a very general level on urban freight and COVID and what's happening with the coronavirus and how has that changed what might be the implications for urban freight planning moving forward. So just to set some context for why we developed the guidebook. Here in New York City and in many cities around the world, we've seen over the last 2 decades a tremendous increase in prioritization of pedestrians and bikes and transit on our urban streets. All of these are good things in terms of making our streets safer, making our streets more livable from a passenger perspective. But often in the discussions that we have about complete streets, freight is discussed in the context of what you're seeing on your screen right now. Basically, freight is viewed as in terms of its negative externalities. Freight vehicles cause dangerous collisions, especially with those non-motorized travelers. Freight vehicles generate air pollution and noise. They contribute to traffic congestion. They obstruct bike lanes. They obstruct bus lanes. And on top of all that, they damage bridges, they damage pavements, they damage other infrastructure. These are all true. Freight does present challenges for each of these externalities on urban streets. What often gets lost, however, and this is something that possibly over the last couple of weeks or a couple of months around the world, the view of this has changed a little bit. But if we think about freight in another way, first, before we get to the freight side, what are the elements of a livable city? So when we think of a livable city, we want a city where people of all ages and abilities have access to affordable and safe housing, to employment opportunities in a variety of sectors, to education, to healthcare, to basic sanitation, and to the everyday necessities that allow us to maintain a basic quality of life. On top of that, we want access to cultural and social and recreational opportunities, which enrich our lives. And we want our communities to be able to access all of these things via a variety of modes of transportation. Now, let's break it down and look at which of these elements can actually function without goods movement. So first, it will be very difficult to build and maintain a housing stock without the ability to move construction materials. It would be very difficult to operate a school without books and food for the students, a hospital without medicine and equipment, basic sanitation without the movement of waste out of the community. It would be difficult to operate our any type of employment opportunities, manufacturing, retail, consumer, even the basic service sector requires material movement of goods. So all of these things rely on goods movement. Even those social and recreational opportunities, we can't have restaurants without food, stores without goods to sell, athletic activities without the equipment that we rely on to actually conduct those. And so essentially, all of that activity relies on some type of goods movement. And if we really want to take this to the extreme, even those modes of transportation cannot function without the basic fuel and the basic materials that we need to actually construct those vehicles. So ultimately what we're left with in the end, I would say if all of these other things go away, we're not going to have a community. So what we're left with is this tree, if it's native and exists in a hospitable environment and doesn't require the movement of specific materials that would be required for maintenance. So, you know, I go through that slide just to emphasize that we are starting from the recognition that goods movement is not just a problem to be eliminated from a livable city, but goods movement is actually critical to the social and economic welfare of a city. We don't want to live in a city like the one on the right, where we have waste piling up, which leads to all kinds of other negative externalities because we don't have efficient and effective goods movement. So starting from that point, and recognizing that freight must coexist in our cities with the other modes of transportation that we're planning for, the purpose of our guidebook is to identify what are the challenges that freight faces and how can these be integrated in a way that supports a livable community and that provides safety for those other modes of transportation, that non-motorized transportation, and allow efficient transit operations at the same time that we still maintain this basic goods movement that's required. So the guidebook was developed in an urban center. As I go through this, you're going to see a lot of pictures of Manhattan. I realize many of you are living in communities that do not look like Manhattan. But we found from our survey across all of those US cities that cities of varying sizes, from the very dense to even relatively limited density, are facing the same challenges. And so this guidebook is not only applicable in dense urban centers, but it's useful in suburban or even exurban areas where you've got freight, warehousing, and industrial development, in suburban or small town main streets or even rural main streets, and in industrial and commercial campuses where you may have people moving to their jobs via transit or on bike or by walking in an area where you're going to have a lot of freight activity. So just to outline the challenges that we're going to go through in a little bit more detail, the first is simply identifying what freight vehicles are actually operating on a street and what freight vehicles need to be designed for when we think about designing and planning a street. The second set of challenges we'll go through are what I classify as vehicle navigation challenges. These are issues that freight vehicles face as they try to move through a community. So as they try to navigate compact intersections, as they try to stay on a specific network, these are the challenges that they're going to face. And then finally, I've got a group of challenges which I call curbside challenges. That's once the freight vehicle actually reaches its destination, what challenges might it face in completing a movement of goods from the curbside into a final destination like a building. So first, when we talk about design and control vehicles, this is common in the complete streets literature. We distinguish between a design vehicle and a control vehicle. So essentially the way I think about this distinction is that a design vehicle is a vehicle that we must design the street for regular operations at all times without impeding on another mode or movement. So basically, the small truck that you can see in the graphic on your screen should be able to navigate this turn directly into the curbside lane without crossing into the path of an adjacent lane in order to make that turn. A control vehicle is a slightly larger vehicle, or maybe a much larger vehicle, that might need to occasionally use the street. In that case, we don't necessarily need to design the street for that vehicle to make that direct curbside to curbside movement, but we might be able to allow that vehicle to use space from an adjacent lane, which would potentially conflict with another vehicle movement. But if it only happens on a very rare occasion, that's going to be a preferred design to designing this intersection for that very large truck all the time, when that's only a very rare occasional movement that needs to happen. Because in that case, we're basically trading off pedestrian safety at all times for this very limited number of truck movements. So one of the biggest challenges we found in talking to cities about how they design their streets for freight is simply having very limited information about what trucks are actually on the road. Often urban areas in the US and around the world collect very limited detail on specific vehicle configurations of what types of trucks are operating on the roadways. So just some examples of things you can look at to try to get a better idea of what freight is actually going to be operating on specific streets. Looking, if you have it, at current freight traffic flows, but if you don't have it, understanding what are the freight generating land uses in the community, looking at street functional classes and network designations. So if you're designing a project and it's on a route that is designated as part of your local truck network, you can probably conclude that there are going to be trucks operating on that roadway. Looking at applicable truck size and weight regulations, this is something that surprised us when we conducted our survey. In many of the cities where we spoke to roadway designers, a number of them were not able to tell us what the largest vehicle that could actually legally operate on their streets is. Not that we should be designing for that largest vehicle, but we at least have to have an understanding of what are the types of vehicles that are operating on the street. And then finally, historic incident data, things like even parking regulation, parking violations, or collisions for which there's some record of the vehicle types involved, can be mined for information about what types of trucks are actually operating on the roadway. What often happens in designing streets for freight is that we generally apply recommendations based on some of the guidance that's out there. So for example, the DL23, which is essentially a small parcel truck, is recommended in the NACTO Urban Street Design Guide as a design vehicle for residential neighborhoods. And for the vast majority of residential neighborhoods, that's probably a good recommendation. But if that residential neighborhood happens to be located nearby a location that would have the occasional very large truck movement, then we might need to tweak our roadway design to accommodate that movement and not end up with unsafe operations in the long run. One other challenge to identifying trucks activity on the street is the fact that freight industry is often not going to be present during typical community outreach activities. So often when we're doing a street redesign project, for example, putting in a bus lane or a bike lane, what we do is we take that project to a community through a community board meeting or through a local church or a local business where we know that we can bring in a wide variety of members of the community to provide feedback on that project. freight is not local. So often the people that are delivering to that neighborhood do not live in that neighborhood. And so when we do community outreach in that way, we're not going to get at freight stakeholders that are actually conducting freight activity in the neighborhood. So there need to be specific outreach activities to engage the freight community. And so these are just some examples. I'm not going to read through all of these in detail. I recommend that you look at my last slide. We've got a link to our guidebook, which will go through these in a great amount, or at least in a little bit more detail, and point you to some really good examples from around the world of how cities are actually engaging their freight communities on an ongoing basis. So the second set of challenges are those navigation challenges. So how does freight actually navigate a city where we have compact intersections and multimodal streets? And probably the most obvious example of a problem that comes to the mind of any member of the general public is that when you have compact intersections and when you have large trucks, they are innately incompatible. So for pedestrians, we want to minimize crossing distances. We want that intersection to be as narrow as possible so that we're minimizing pedestrian risk. However, a large vehicle is not going to be able to navigate an intersection that is extremely compact without explicitly designing for its use. So fortunately, there are a number of ways that we can actually enable those large vehicles to still operate at a compact intersection. And there are several examples of just small tweaks that can be made to the design to allow larger vehicles to operate within those compact intersections. You can see on the slide 3 examples of those. So one, just simply maintaining something else at the curb other than an active travel lane. So if a vehicle does not have to navigate from immediately adjacent to the curb as it approaches that turn, it actually is going to have more space for turning. So having a curbside bike lane or a curbside parking lane or other things like a parklet in that space actually provides additional space for that vehicle to navigate the turn. In the center, you can see an asymmetrical median nose. This is an example where if you had put a typical median here with a symmetric nose, the truck would actually not be able to navigate this turn. But just by slightly tweaking the design of that median, yes, we do lose a little bit of the sheltered space that we would get with a symmetric median nose, but we've still got some pedestrian protection, and we're enabling that larger truck in order to actually navigate the turn. Finally, on the right, you see a recessed stop line. Again, these are documented not just for freight applications, but for buses and any other large vehicle navigating a compact turn. If you can move the stop line back away from the intersection, it actually can allow that vehicle to use part of the adjacent lane in order to navigate that turn. Now, at the bottom, what you see are solutions that are using paint or allowing vehicles to actually navigate up onto what typically would require them to make a change to drive up onto a curb to actually make a turning movement. So on the left, the photograph you see on the left, I think is actually a temporary treatment from here in New York City. But you can see this is a place where instead of putting a concrete curb so far, we are still taking back some of that street space, allowing that and designating that as pedestrian street space, but doing so without actually requiring a large vehicle making that turn that might need to navigate into that space on an occasional basis from having to actually mount the curb to do so. On the right, same thing, we've got a flush pavement. This is actually an example from Portland, Oregon. I think this is likely put in for a bus to navigate this turn as opposed to a truck. But this is where you've got an occasional vehicle that might need to navigate this compact turn. It may be a better solution to allow once an hour or a couple times a day, a truck to actually cross over part of the sidewalk, which is clearly designated using pavement texturing, rather than requiring that entire intersection to be wider. So these are all design solutions that can be used to allow those large vehicles to still navigate at an intersection that we're trying to maintain that compactness for pedestrians. We can also try to implement a regulatory solution. And again, often this is what we read is the solution. Well, the trucks are too big. We just need to limit the size of the trucks that are operating on the street. Large vehicles should not be sharing space with, non-motorized travelers. And in theory, this is a true statement. We can limit the number of large vehicles by simply putting in restrictions. However, we need to be careful in doing that, because when we do limit the size of vehicles that can operate in an area, we may be having unintended consequences for doing so. So we may limit the size of trucks that can operate at all times of day in that fixed system. We may limit the size of trucks that can operate, for example, in Seattle, they limit the size of trucks that can operate in their business district during business hours. Again, it will limit the number of large vehicles on the road, but in doing that, we may be, for example, increasing the number of smaller trucks that are operating on the road, in which case we may get counterproductive impacts for the total vehicle miles traveled by trucks on the road. We may get increased impacts on congestion. And probably more critically, we may also be impacting operator costs and industry willingness to actually serve an area. So if we ban certain size trucks from operating in a business district, and in doing so, we increase the cost of goods actually moving into that area, we can actually have downstream consequences on who chooses to locate their businesses in that area. And if they choose not to locate their business in that area, then there's going to be wider economic consequences for my city. So regulatory solutions are one way of doing this, and are something that should be considered, especially when safety is the first priority. However, they cannot be considered in isolation. They need to be considered looking at all of these other impacts that might result when we actually restrict the size of vehicles that are operating on the street. And we'll come back and touch on this at the end when we talk about demand management. So from an operational perspective, we can do the same thing that we do with those design solutions, where we can actually use signal timings by separating out specific types of movements at specifically designed intersections. We may be able to enable the use of adjacent lanes in order for vehicles to navigate turning movements, which can then allow wider turns at those intersections. So the large vehicles are probably the most obvious problem that freight is going to face when operating in a complete streets or area with compact streets. However, probably the most critical one in the eyes of public policy and in basic human decency is the conflicts that occur between freight and vulnerable roadway users. Because these conflicts are disproportionately fatal. We know that collisions involving large vehicles are more likely to result in a serious injury or fatality than those involving smaller vehicles. So these are really serious incidents, and we need to find ways to ultimately eliminate and certainly mitigate the impacts of these large vehicles in urban areas. So the first, and again, fairly obvious solution is simply by having designated infrastructure for bikes and for pedestrians, and by clearly identifying the conflict zones that exist. So on the screen, you can see a couple of examples. So having bike boxes, which actually move the cyclist in front of the driver's blind spot so that they can see that a conflict might be occurring. Having two-phase turn cue boxes so that bikes don't need to navigate across several lanes in order to make a left turn. Having the paint on the sidewalk here, which designates a loading area, so that you recognize that this is not just a normal sidewalk, there's something else going on here. Again, same with the paint through the intersection on the right. Again, we can take an operational approach when we have a designated phases for bikes and for pedestrians. Separating out the phasing at the intersection allows for a time for those modes to move and eliminating those conflicts. On the right, this is an example. This is actually from a bus stop in Copenhagen. This is a bus stop located adjacent to a bike lane where clearly there was a problem with the bus drivers not being able to see behind them to see an oncoming bike. These types of mirrors are not commonly used in the US. They're not in the MUTCD as an approved traffic control device, but they are commonly used in urban areas at driveway locations and other places where you might have a driver coming out of a enclosed driveway, for example, crossing a sidewalk, needing to be able to see around the turn to see into that sidewalk to see if there's a conflict coming. So these are all operational solutions. And then for safety, there's a whole lot we can do on the vehicle side. So in Europe, most European countries actually have mandates for a variety of types of mirrors that see into several blind spots on that a truck driver would have while navigating the streets. In the US, we do not have many mandates for these safety mirrors. In New York, we do have a requirement for crossover mirrors so that a driver driving a very large truck into essentially New York City can see if there's a pedestrian and crossing in front of their vehicle, but we don't have a whole lot of mandates for these mirrors. Fresnel safety lenses are a very low cost solution. It's essentially a small plastic lens that you can attach to a driver's window to minimize some of those blind spots. There are more high-tech solutions like cameras and sensors that can be installed on a vehicle to detect potential conflicts coming in a blind spot. Truck side guards, as you can see on the right, are a solution. Again, these are common in Europe. They are growing in the US. The city of Boston actually tried to mandate them for all vehicles operating in the city. They basically found that that policy was not enforceable with all of the interstate commerce operating in the region. However, side guards are still mandated for fleets that are working on city contracts. So the city cannot mandate or has not been effective in mandating side guards on all trucks entering the city, but they have been effective in mandating them for trucks that are specifically serving city contracts. Now those side guards, the benefit of that side guard is not that it's actually going to prevent a collision from happening. What it's going to do is reduce the severity of that collision. What that side guard does is it prevents a cyclist who would collide with that truck from being pulled under the tires of the truck, which obviously would lead to a much worse outcome for the cyclist than simply I guess bumping into the truck as it's navigating the street. I think most interestingly on the vehicle-based solution side is something that's happening in the City of London right now, which is by the end of this year, they will have implemented direct vision standards, which essentially provides a rating system for trucks based on the amount of blind spots that they have by the volume of blind spots that you would have sitting in the cab of that truck. And trucks that are designed with too much blind area will essentially not be allowed to operate on the city streets. So why I think this is an interesting solution is it's actually taking the problem not in trying to regulate a set of trucks, but it's actually sort of bumping the problem back to the manufacturer to think about in the design of the vehicle, how can we actually better design these trucks so that they don't have blind spots, so that those blind spots don't exist as the driver is actually navigating the street. And so that should be implemented by the end of this year and phased in with greater, higher standards over the next 4 to 5 years. On the education side for safety, there's a lot that can be done, and this can be relatively low-hanging fruit. The picture that you see is from the bike share system here in New York. These are just stickers that are on the city bikes, reminding the cyclist that's actually using that bike that trucks do have blind spots and that you should provide space. There are specific education programs. So again, an example from here in New York, as part of the Summer Streets program, New York City DOT brings a large truck to those Summer Streets events and actually allow members of the general public to climb up into the cab of the truck so that they get a better understanding of what the truck driver can actually see when they're driving that truck. As part of the fleet operator recognition scheme in the UK, the opposite is actually done. They actually put truck drivers onto bicycles and allow them to navigate the street from the perspective of the cyclist to understand what the cyclists can see and experience as they navigate the streets. I think it's really interesting that we have both of these examples that sort of demonstrate that the real challenge is in all of the users of the street better understanding the perspective of the other users of the street so that we can eliminate as many of those conflicts as possible. So the third challenge on the navigation side, I'm going to move through very quickly. This is just often the types of implementations that we put in to try to reduce speeds in a community can be problematic for large vehicles to navigate. For example, a roundabout with raised center islands and raised crossover islands might present a challenge to a large vehicle with a high center of gravity being able to navigate a circular path. Similarly, speed bumps that go all the way across the full width of a roadway. If a truck actually experiences vertical displacement, there's potential that the load on that truck can actually be damaged. So these are just a couple of, again, small tweaks to designs that can be made. So if we use speed humps instead of speed bumps, these speed humps do not actually allow a wide wheelbase vehicle to pass over without actually being vertically displaced. It doesn't mean that the truck can blow through here at high speed in order to navigate over the speed hump without hitting it. The truck still needs to reduce their speed, but it doesn't actually experience that vertical displacement. Similarly, a mini roundabout with a flush center island or flush splitter islands could actually allow a truck to turn directly left over that center island so that it doesn't actually have to navigate that circular path that would present a dangerous condition to the truck driver. So the last topic on navigability is network connectivity and redundancy. This is a little bit less difficult to, or more difficult to define specifically, but essentially, frequently when we implement street design projects and make changes to the design of the street, it can have a network level impact on the truck network. So for example, I'll show you on the next slide a picture of a project in Brooklyn where we had a two-way truck route on which major bike infrastructure was installed. So the initial design for that project actually eliminated all parking and maintained two-way traffic movements in order to make space for the bike lane. In doing so, we eliminated all loading at the curbside, which became problematic for the industrial land uses that were adjacent to that. And so the street was then redesigned again, changing that two-way truck route from a one-way truck route, which solved the initial problem that we found, or that was identified. But ultimately, the new design changed that to a one-way truck route. And in doing that, it eliminated part of the defined truck route network in the city. What happens now is drivers arrive to the north end of that location, and then they have to make a decision to stay on the actually legally mandated truck route and navigate a much longer path in order to stay on that truck route, or to choose to travel on streets that they're not really supposed to be traveling on as part of the truck route network and maintain a relatively shorter path. In doing that, we basically created a network level navigation problem for the trucks. So in implementing street design projects, we just need to recognize that when we make changes to streets that are used as part of the truck route network or commonly used by trucks, we need to think about what are the alternative routes that they're actually going to use if that network piece is eliminated, and how is that going to, what's the impact of that going to be? Is it likely to drive trucks onto streets? There is not really a reasonable alternative, in which case they may start to operate in a way that they shouldn't be in order to maintain an efficient route. Or if they do use the legal route, are we increasing VMT? Are we increasing risk somewhere else in the network because we're now driving up the mileage for trucks operating in our network? So just thinking about it from kind of a network perspective. Okay, so now I get to the third set of challenges. This is what happens once the vehicle actually reaches its endpoint and some type of delivery activity has to happen. These are all examples of pictures from here in New York City. The one on the left, you can see just off screen to the left of that picture is a protected bike lane. So we have a parking protected bike lane. And then you can see adjacent to that, we have relatively narrow travel lanes. This truck is actually perfectly legally parked. It is legal to double park your truck for expeditious loading in this location. But you can see because of the width of that travel lane and the type of delivery that's happening. So this is a beverage delivery, which is going to be common in a place where you've got restaurants and bars. They have side loading trucks. And so this operator is parked in one travel lane and standing very precariously in a second active travel lane simply to get the goods off of his truck. Frequently, as we assign the curb for other curbside uses, parking is eliminated. Again, I have no general objection to reducing the amount of parking on the street, but if that parking is particularly targeted in an area where there is a lot of truck loading activity and the truck still needs to get goods that may be heavy to move to a location in that place, we're going to have a problem and we're going to end up with trucks parked where they're not supposed to be. And then finally at the bottom, you can see that we don't just need to think about the truck itself or the size of the truck, but also the loading activity that's going to occur. So here you can see this is a truck parked in a loading zone. It's, again, perfectly legally parked, but the length of that loading zone, once the driver actually deploys that lift gate in order to get the goods off of the truck, he's now obstructing the crosswalk because the length of that space is not long enough to actually allow for that gate to be deployed. So again, just some small design tweaks that have been done around the world. In the center, you see a offset bus lane. So many of the initial bus lanes that were put in here in New York and in other cities were installed as curbside bus lanes. And that's for a very good reason from a transit perspective. We want to maintain online bus loading. Anytime that bus leaves its travel lane, it's going to experience delay as it needs to re-enter the travel lane. So initially, many of the bus lanes were put in as curbside lanes. What happened was we ended up with a lot of trucks obstructing those bus lanes because they still needed access to the curb in order to conduct their loading activities. So now in New York, and the city has done a great job of coming up with this design, which is much more common now, where you actually have that offset bus lane and have maintained that online loading by using transit bulbs at the intersection. So by having the transit bulb, we can allow online bus loading. The bus never needs to leave the lane, but we still have that curbside access for the freight activity that needs to occur. The solution you see on the right is similar in Paris. So when Paris installed curbside bus and bike lanes, again, it eliminated a lot of direct curb access for loading activity. Now in Paris, there was not a tremendous amount of excess space on the street to accommodate an additional lane of movement. So in this location and in many other locations in the city where the excess space was actually on the sidewalk side, they're using these partial or full cutouts to actually provide a loading space in that area. From a regulatory perspective, again, in the US, many of our land use regulations have not been updated in a very long time. Loading dock requirements here in New York have not been updated since the early 1970s. Freight demand patterns have changed tremendously since the 1970s. They've changed tremendously since 2018. And so we need to recognize that when we have buildings, so for example, a large residential building in Manhattan might have 1,000 apartment units. If everyone in that building gets 2 deliveries a week, which is not an unreasonable estimate at all, there are 2,000 packages a week coming through the front door of that building. Our zoning standards right now have 0 requirement for any loading space at that location because it's a residential land use. So we need to look at those land use requirements and see how they can be updated. Now, they're not necessarily going to be effective for existing buildings, but especially as we develop new development, how can we account for that? So operationally, one key point I want to emphasize is that regulation of on-street activity is not the only way to try to address this problem. There was a really good study done by our colleagues at the Urban Freight Lab in Seattle that actually quantified the amount of time that could be saved in an office building if deliveries were made to a centralized ground floor delivery point instead of by having the drivers actually have to navigate the building in order to conduct that delivery activity. And it's a sample size of 1, so it's a very specific location, but they found 78% of the parking time could be eliminated if we had better management of what was happening off street. And so when we think about operational solutions, we often talk about enforcement and we want to write tickets. But the problem, or the real root of the challenge, is that the demand exists. And as long as there are customers in that building requesting a delivery, that delivery is going to be made. And enforcement is going to be only of limited effectiveness if that is a time-constrained demand that must be met. And so there are other ways that we can better manage this by looking off-street. So last point with these challenges is that we also need to think of the actual freight operator as a human being and as someone who needs to be able to safely navigate to actually make the delivery. This is an example from Midtown Manhattan on the left side. You may not be obvious to you when you first glance at the picture. This is a driver who just walked down an active travel lane in the middle of Midtown Manhattan from a parking space located off the curb, separated from the curb from by this bike lane that you can see in the picture. There is no way for him to access the curb from the middle of the lane. So if he's got goods that he can't lift 6 inches to get onto that curb, he actually needs to walk to the corner in order to get on. And so we're creating very unsafe conditions for this individual in the design that we've put in place. On the right, this is just an example. There can be all kinds of obstructions at a loading zone on a sidewalk. So from a design perspective, main key point is that we need to think about the safety of the operator. We need to think about the physical space for the vehicle. And so we need to maintain a vertical clearance zone, a horizontal clearance zone, and possibly even mid-block curb cuts to allow these operators to safely get where they need to be at the curbside. So with that, my last comments on demand management. So we frequently talk about freight, again, as something that we want to move to shift into a less conflicting time period. So ideally in an urban area, we would want the trucks to come in overnight when no one else needs to use the road. And that way we've eliminated the conflict by shifting them in time. This is just one example. The challenge becomes that these types of solutions are only effective if there's investments made to enable them, and if they are actually implemented only when the costs are acceptable to decision makers. So just some examples, off-hour deliveries are frequently cited as a solution. They absolutely are an effective solution for certain types of businesses in certain types of communities. So off-hour deliveries, we want to shift deliveries to non-peak hours. There are a lot of benefits to these. For the operator, these are great for the operator. They don't get parking tickets. They don't travel in congestion. They don't burn excess fuel. For the businesses, they can get their deliveries when customers aren't present. And for the neighborhood, it can reduce congestion impacts and reduce demand for shared curb space. But there are also some very real challenges that prevent these from happening. First, from a supply chain perspective, the cost structure might be different. If a driver's coming in late at night instead of during the day, you may have to pay them a premium. The driver may also be at a safety risk making that delivery late at night when there's not people around. For the business who's the receiver may actually have to pay staff costs for someone to accept that off-hour delivery. Now, there are definitely technology solutions and other solutions where we can get at some of these challenges, but they're not going to fix themselves. They're issues that we need to think through. And then from the neighborhood, we don't want to have trucks outside of our apartment at 4 o'clock in the morning, waking us up at night. So we need to think about that. Similarly, consolidation centers are often viewed as a good solution. And again, there are very good examples around the world where they have worked. That's where we bring goods in on a large vehicle, transfer them to smaller vehicles that are more friendly to these multimodal streets for final delivery. These can be effective, but they are very difficult to make work economically. So if a vehicle is efficiently moving a large volume of goods, and we now take that and put it onto smaller vehicles, we're increasing the cost to actually move those goods. That may be a cost that we're willing to bear, but it's a cost that we need to think about. And then finally, lockers and pickup points are a very increasingly common solution, probably more so in the European context so far than in the US context, but it's certainly increasing around the world, where we have a secure locker bank where you can have your delivery delivered to a locker or to a local store or a pharmacy where you pick up your package at that location instead of at the locker. Again, the benefit of this is it's densifying that demand. E-commerce is a very disaggregated demand. You have deliveries coming at all times of day at varying speeds from 1 hour to 1 week to several weeks. And those demands are going to arrive in very small shipments, which requires very inefficient delivery to get them there. And so the more that we can densify those by having a centralized point, we can eliminate a lot of the inefficiencies that are associated with that. So again, I know I went through these last couple slides. I'm running a little bit slow here. So I'm not going through every detail on these slides, but just recognizing that density in general is a good thing. These are good solutions from that perspective in reducing the impact of these modes on the street, but that they come with real challenges in terms of where do you actually locate these things. You need space and you need them to be in a secure location for people to actually use them. So with that, I'm not going to spend a lot of time on it, but I did want to quickly touch on the COVID and urban goods movement. What have we seen over the last couple of weeks? I think first and foremost, as I started off kind of talking about the critical role that freight plays in cities, I think it's become increasingly obvious, we don't think about it on a daily basis. How do our groceries get to the grocery store? But suddenly when the most important thing we're thinking about is how do we get our groceries, the supply chain and the truck drivers that operate that supply chain suddenly move to a much higher priority in our minds in terms of the role that they play in society. So they play that role every day, but there's not any emphasis on it until we're facing a situation like we do right now. So the current situation has raised a lot of urban freight related issues. For example, how do people get access to food and medicine? Under normal conditions, most people go to the store, obtain those goods and go home. Now we've got a large percentage of people that are looking to have those things directly delivered to their home. Looking forward, we have a lot of issues we're going to need to deal with. So who has access to those available services? Are there some communities that should be prioritized for home delivery versus having to go to a store, particularly in the current environment, higher risk versus lower risk? A second thing that's been shown out of the current activities is that we have very segmented supply chains. So right now we've got our food supply chains that serve our grocery stores that bring food to us. And then we've got our food supply chains that serve commercial establishments or serve schools. And what we're seeing is probably moving forward, we need to think about the integration of those supply chains because we've got, grocery stores with no milk on the shelves, but we've got operators, farmers dumping milk because they can't get it into those commercial supply chains, which no longer have demand for it. And so that's an issue we're going to need to think about. The role of the shared economy, how do we take advantage of shared economy to change the way that people actually have access to those goods? And then I have question mark with the role of density here, because much like we talk about with public transportation, those last couple of demand management solutions I just went through, we view density as a good thing. We want people to go pick up their packages in a location where other people are also picking up their packages. And I think as we move out of this COVID, we're going to need to think about the role of density. So with that, I'm going to acknowledge our sponsors and our partners on this project, particularly NYSERDA, who funded development of the guidebook, New York City Department of Transportation, who is our partner, and the Volvo Research and Education Foundation through the Metro Freight Center, who actually funded the preliminary research that led us to this project to begin with. So with that, I am happy to take questions.
Great, thank you so much, Allison. And for folks who had entered questions on how to access the guidebook, please see it here on the screen. And please note that we will also email it to you and have it available on the ITDP website. So I can go ahead, Allison, and kick us off with the Q&A with this question at the top that we have from Daniel. Thank you for entering this. In part of your presentation, you touched upon the community engagement piece and how oftentimes that is lost when we are thinking of freight because these deliveries or these routes are coming from outside of the neighborhood. So with this in mind, can you give any examples or strategies for how people work with taking away parking spaces and integrating freight as a part of the network?
Sure. So, I don't have a specific example where a city has been really successful in doing this. Parking is a very sensitive issue in a community. Anywhere where parking free, we can use the term free parking for residential benefit is in a community. It's going to be very sensitive when you start to take that away. New York City actually has implemented a program. They call them neighborhood loading zones, where they are trying to allocate space specifically for these types of delivery activities. My understanding is that it's been fairly successful, but there does need to be sort of an education campaign. And again, maybe with the current pandemic, as people recognize how critical these goods movements are to themselves and to their community members, it may sort of increase the prioritization of that in the mind of how freight actually affects the basic community. But again, New York has the neighborhood loading zone program. That's the best individual example I can think of.
Great, thank you, Allison. The next questions here I'm going to combine because there were a few folks interested in hearing more about examples in the Global South. So do you have any recommendations as some cities in the Global South grapple with urban highways and how that fits in with their regular network and complicating and finding solutions to have these delivery services? And then second to that, how to deal with these increased conflicts that trucks and delivery services have with pedestrians and cyclists. The question here included how oftentimes in African and Asian cities, there is much goods movement, and I would add Latin America as well, goods movement using hand carts. So how can we accommodate all these different users on the road as people deliver these goods?
Yeah, and so I will preface it with, I have not done a tremendous amount of work in the Global South, so I do not at all claim to be a complete expert in that topic. I do think it makes for an interesting parallel when you compare what's happening in Western cities and in the Global South, in that we are talking about solutions which are things that have already been done in the Global South. So we're talking about trying to move goods back onto bikes and trying to find ways to accommodate more movements by hand carts by having a consolidation solution. So I think these are solutions that we need to look at jointly and try to come up with ways that we can manage in cities all around the globe to try to better integrate these solutions. In terms of street design, I would just say, again, it may be that those types of consolidation solutions, better organization of those activities might be an interesting solution to look at, kind of coming at it from the opposite perspective, which is trying to better organize those non-motorized activities in addition to reducing the truck trips coming in. So looking at that solution from kind of both perspectives.
Great, thank you, Allison. The next question here is from Jose. Thank you, Jose, for submitting this. Earlier in the presentation, you touched upon how we can better understand our data points through the role of technology and how we can use technology to better map these services. So with this in mind, do you have an example or a recommendation for using information technology or maps such as Waze or Google to better understand freight routes so that these trucks aren't being directed to streets where they can't really maneuver the area or are not allowed on those roads?
Sure. So this is an interesting question, and it's actually one that we see a lot of challenges because of those navigation technologies. We actually have a big problem here in New York State, for example, with bridge hits, because there are drivers using technology systems that were not developed specifically for freight operations. And that technology is telling them to take a specific route that does not have any sort of regulatory limits programmed into it. And then they end up driving on a parkway that has a low bridge and end up actually hitting that bridge. So this is actually a really important issue, as to how do we integrate these technology systems to better route vehicles onto the routes that they need to be on. I would say there has been, a lot of activity in recent years using data mined from those systems to better understand freight problems and freight challenges. So understanding where are freight origins and destinations. When you have the breadcrumb data, figuring out which routes that the vehicles are actually using, as long as you can distinguish the trucks from the personal vehicles or passenger vehicles, then you can use that information. I will say, though, there's a caveat with that, is that particularly in the urban environment, and especially particularly as we move towards these like e-commerce based solutions, it's not going to be as easy to distinguish a truck that's conducting freight activity from or a vehicle that's conducting freight activity from a passenger vehicle. As you can see, as we had this growth in on-demand e-commerce in the cities, we're not using large trucks to move those e-commerce goods. We're using bicycles, we're using passenger cars, and we're using these, unmarked white delivery vans that, from glancing at from the street, might be a passenger van, might be a freight van. So I think that's actually a really important research moving forward that we need to think about, is how can we improve our technology systems and make better use of this data and develop those systems in a way that we can actually better capture that information.
Great, thank you, Allison. And at the tail end of your comment, you pointed to how increasingly with e-commerce, there are more cities looking to bike deliveries to do kind of these last mile connections. And there are some questions here that I can combine that also point to that. Do you see any trends, or can you touch upon the potential of more e-cargo bike deliveries, or just cargo bikes in general, if they're not electric, and if there are some examples of cities that are doing it very well?
Yeah, so there are absolutely a lot of ways in which we can make use of cargo bikes for specific types of good movements. So cargo bikes are a really great solution when you have a dense market where streets are much more easily navigable by those bikes. You can, have a bike that moves faster and can park more reliably than a motorized vehicle. The challenge with cargo bikes is just, as you might imagine from the size, is there's limits on the economies of scale that you can obtain from those types of operations. So again, here in New York, we have a pilot going on looking at most of the applications, I think, are doing local deliveries. So things like grocery deliveries and doing parcel deliveries. So major operators like UPS and DHL are engaged in that pilot. Again, there are a number of European cities, for example, in Gothenburg in Sweden, in their central business district, which is primarily pedestrian oriented. They have consolidated their delivery activities to particularly to small businesses, where those deliveries come to a centralized location, and then they're delivered via cargo bikes and other smaller slow speed vehicles that are more friendly. Again, the challenge with these operations is just that when you lose economies of scale, you can also increase the cost of those operations. So when you've got small volumes moving on those vehicles, you just need to look carefully at what those costs are. And it might make sense that, if a city really wants to improve safety in a dense area, that they invest in space, or they provide public space for consolidation activity to occur, to kind of help advance those types of solutions. And with that, I will say that there are locations where those solutions economically make sense without any sort of intervention from the public sector, where just simply the cost savings from
not getting parking tickets and from not wasting fuel, and where freight operations weren't particularly efficient to begin with, the cargo bike can be a more effective solution.
Great, thank you, Allison. So it seems that we are already out of time, but thank you to those who have submitted these questions, and I can make sure to share them with Allison to see how we can further explore those. But overall, I would just like to thank you, Allison, again for this great presentation and also sharing your insights and kind of just a general pulse of your thoughts on COVID and freight deliveries, as a lot of these access to goods and supply chains is on the tips of our minds these days. And then lastly, of course, I would like to thank our attendees, to you for joining our webinar today and for engaging us. As mentioned earlier, this webinar recording and PowerPoint will be available to you on email and also on our website. So again, thank you everyone for joining us. We hope to see you online soon again, and please stay safe and healthy until we meet again. Thank you.
Thanks.